Good morning and welcome to the 20th annual exhibit of hydrogen and fuel cells. This year we've added batteries to the mix, so we're getting more versatile. We've been here for a long time talking about fuel cell technology, hydrogen, and the way this is going to influence the coming energy sector. On that issue, we have a specialist to talk about solid oxide fuel cells with us today. We'll be talking with Yeshwanth Narendar. He's the business manager at Saint-Gobain Corporation, and we'll be talking about the value proposition of the industry's first all-ceramic solid oxide fuel cell stack. Please welcome with me Narendar.
Thank you.
Good morning. I suppose the first question for those who don't know, because I'm so astonished, it's a massive company, but could you tell us a little bit about Saint-Gobain, the corporation?
Yeah, Saint-Gobain is a diversified industrial company based in Paris, and what is not known to a lot of people, we started the company in 1665, so it's been around for a long time.
You personally didn't start it in 1665, I hope.
I feel the passion right from 1665.
Okay.
Yeah.
So you started in 1665, and of course, in the past 20, 50 years, what are your specialties?
So we are working on many different, as you said, diversified, but our focus is really materials and components for energy efficiency, for living environments, and also for making the environment better. So that's been a core aspect of our business. Yeah.
So I'm always interested in why large corporations actually move into the fuel cell industry. Often there's specific expertise, advantages that companies have. They have a knowledge base, perhaps, specific materials that they work with. How did you move into the fuel cell sector? What got you moving in this direction?
That's a good question. So I think it's a combination of two things. One is the competency within the company. We are a large ceramic company, very versed in this kind of technology, and also the strategic interest of Saint-Gobain to be in energy efficiency helps anchor the project within the company, in my opinion. So we are running this project, we started in 2005 in a serious way. We have been developing that, and 2013 was the first year that we started publicly presenting our technology to the audience worldwide and to the industry.
Okay. 2005 to 2013, now you're presenting stuff. Before we get to the solid oxide fuel cell itself that we want to talk about in detail today, I always like to ask the sort of general question. There are various fuel cell types on the market. They all have their particular issues. They all have their potentially expensive materials. What is really interesting and specific about the solid oxide fuel cell? What are the pluses of the solid oxide fuel cell?
So, I mean, I'm going to simplify it for people who are solid oxide fuel cell specialists. Please excuse me for the simplification. But you could almost look at these as a stack of ceramic plates, ceramic cells, where the action happens and the electricity is produced, and metal plates. So it's almost like an assembly of that, right? These operate at high temperature, like 700 to 800 degrees C. And the big benefit is it's very robust. You can put any kind of hydrocarbon in it. You don't need just pure hydrogen. You're able to use natural gas, propane, kerosene, or, for example, biogas, right? But that alone is not sufficient. I mean, the big point about SOFC is that it has very high electric efficiency, right? So you can get up to 60% conversion efficiency, which means you use very little hydrocarbons, and in the process decrease your CO2 emissions. People say that the industry reports are between 35 to 40% CO2 emissions can happen with use of SOFC. Yeah. So that's the big benefit, I think. But there's one important point in that, right? For this to be actually practically happen and realize the benefit for the consumer, you need to do two things. You have to have a low capital cost, and you have to be able to get a long lifetime. So those are very important. Yeah.
Okay, I find that incredibly important because there are the tree huggers here who want us all to use pure hydrogen, but we're stuck right now with the fossil fuels. However, with this technology, we already get the advantage of more efficiency, which drops our CO2 emissions. And these are European targets, so they're very important here. 30% drop in CO2 emissions is just wonderful. You mentioned, though, the issues. And in order to implement this technology, we have to address, from the user side, what is the lifespan? What are the material costs? The capital costs. So why don't we start with the lifespan issue? Everyone has this issue to address. You have a specific take on the lifespan.
Right. I think, it's best to start from the fact that in Saint-Gobain, we also started with metal interconnects and ceramic cells, like most other developers. And we ran this project, and we kind of firsthand realized some of the issues of lifetime and durability ourselves, right? So now, what we find is, on the lifetime issues, there's one basic problem. You have metal, and you have a ceramic cell, and you have poisoning from the metal to the ceramic cells that reduces its performance over time, which we call degradation or a lifetime issue, right? But there's another problem. We want fuel cells to keep running, but you have to turn them off and you have to turn them on. So when you do that, you have metal layers and ceramic layers that are not fully compatible with each other, right? And so at these interfaces, you can have a break or failures that then lead to a reliability issue, which is the second problem of the fuel cells that need to be addressed, right? So when we did our analysis, we decided to go with a very different approach. So what we did is we took out the metal interconnects completely and replaced that with a very thin ceramic interconnect. And that leads to what we call an all-ceramic stack technology, which is what we are presenting today. Yeah.
I believe, actually, we have a slide of the material here.
So yeah, this just gives us a single slide that just shows, our base module, which is about 150 watts, and talks about the fact that you have a thin ceramic interconnect, an all-ceramic structure, and a thin electrolyte that ensures high performance with good reliability. Yeah.
Okay, when we talk about the way these things operate, you mentioned this one thing I think it's important to emphasize, the metal-ceramic issue. It's not a perfect marriage, and particularly with the cycling of off and on, deterioration. So you've really addressed one of the big issues here, that is the threat to standard solid oxide fuel cells of just turning things off and on repeatedly.
Right.
That must be interesting from the side of applications. If you have applications where they're continuously running, it may not be an issue. But if you have applications where the things are being turned off and on...
right, absolutely right. I mean, because when you think about it, when we started this thing and we said we switched the metal to a ceramic interconnect, one of the first things we had to do is run these stacks. So we have now tested them for over 10,000 hours. We are able to get very low degradation rates of 0.2% per 1,000 hours. So that was, I would say, a validation of the idea that we can go to a ceramic interconnect from metal and make that work. And then what we have also done is done multiple on-off cycles for these stacks, show that they are robust after that, including, I would throw out an industry jargon called redox cycles. So they are also capable of handling that specific application issue unique to solid oxide fuel cells, which is redox cycles, right? And all of this comes with a good performance and ability to utilize a lot of the natural gas or hydrocarbons that you put inside that ensures good efficiency. Yeah.
Okay. Just on a side note here, people talk about the operating temperatures of solid oxide fuel cells, with various different temperatures being advantageous or disadvantageous, higher temperatures that may increase degradation. Do you have a favorite temperature?
Yeah, that's a good question, actually. So given that it's an all-ceramic stack with ceramic interconnects, we typically prefer about an 800 degrees C operational temperature. So we are a little bit on the higher end, if you will, compared to a lot of where the solid oxide fuel cell industry is going today. Yeah, but when we do our testing, we typically test in the temperatures of operation to be sure that we are consistent in that temperature and reliable at that temperature. Yeah.
So this already has an influence on the application side, because you really want to have this built into a unit that offers you the recovery of that heat. Combined heat and power is sort of the end application.
Absolutely.
Okay. Now, the design sounds fascinating, wonderful, very innovative. There's always the question of material costs and processing costs. Some things are very difficult and expensive to assemble. Some things are easier. So what have you done in terms of cost, material cost, and processing costs?
So, I think when we think about these fuel cells, the first choice is the materials that you make, so that you use in this. So we have made sure that we don't use any rare or exotic materials, raw materials, or of course precious metals. There are no precious metals in the structure. And we also make sure that it's an all ceramic stack, so we have no specialized alloys, high temperature alloys that are used, for example, in metal interconnects. That helps keeps the material cost down. The second thing is we make 80% of the raw materials ourselves using quite a unique process. That way we can control cost, but also the quality, because being able to control quality helps keep your manufacturing cost down too, right? Yeah. So that's one side on the material cost. On the process cost side, we have a very unique, and I would say that's the most innovative part of the process, is you see those cells that are there, you see multiple layers that are there. Now those cells, usually you fire each cell with multiple heating and cooling cycles to make a cell, which increases a lot of the energy cost, right? What we do is we make multiple cells in one heating cycle. That is a dramatic saving both on energy costs and labor cost, help keeping overall costs down, right? So as I'd mentioned in the past, right, we had made our own type of metal interconnect stack with ceramic cells before. So if you compare our initial development to this development that we are making today with an all ceramic stack, we are expecting over 50% reduction in costs compared to the first technology that we were practicing. So which is what makes us really excited about it.
I should add, if there are questions from the audience, feel free to raise your hand, and we'll bring a microphone to you.
Please.
First question is, what's the maximum size you're targeting for the fuel cell? And the second one is, will you be able to also run ammonia in the cell?
Okay. So in the case of the size, at the first outset, the generation 1, we are targeting like each little building block is 150 watts. And then we are putting them together to get to 1.5 kilowatts up to 10 kilowatts.
But not very large scale.
No, not very large scale. Not at the first point, but here we have to stay, right? SOFC is modular. So, and this is sort of our core belief that you first have to have lower power applications that come on board, where the technology, people get confidence in the technology, and then the larger applications will follow. That's our view. Yeah. Yes, we have not done it so far, but we believe yes. Yeah.
If there are any more questions, just raise your hand. I certainly would like to continue on the topic of applications. Modularity and the small size, it sounds very flexible, but what are really the target applications where these solutions, for instance, the on-off cycling problem is solved, the modular structure is given? What are the specific applications that you're thinking of?
Yeah, we are looking at lower power stationary applications. That's really our main focus right now. So we like residential applications, small commercial applications at this current moment. And the reason we also put a lot of emphasis on the on-off cycling is in a residential application, you should give the homeowner the ability to turn the system off when they want. So you need to be able to handle that kind of on-off cycling. So I think that's our initial target. But again, as I mentioned, once we have confidence in that lower power segment, I think the higher power applications can follow. Yeah.
Okay. I believe we did have another slide here. I'm not sure if we've covered. This is an example of the system. Am I correct?
Yeah. So I think one point that was unique to our development is we are, as we know, a materials and a ceramics company, right? So we make our powders, we make our glasses, we make our stack. We want to then have some manifolds that supply gas, be able to pull current out from the stack, and we want to hand that off to a system partner or a system integrator. We don't want to go all the way to the end consumer. So I think we just want to make that very clear that that's our business model, that we will stop at the stack and the stack module, and then currently right now we are working with multiple downstream partners to reach end customers in Europe or Japan. Yeah, so that's the way we want to approach the market.
Okay, so you're not out there to compete with the other systems integrators
No.
and marketers, but to use their expertise in marketing and system integration,
Right.
but to give them the better heart for the whole animal.
Yes, you could clearly say it like that. That's a nice way to put it, actually. Yeah.
Okay,
Yeah.
okay. We sort of skipped one step in the conversation here, but the stationary applications, I've seen two very popular applications. They're both stationary, single-family dwelling energy suppliers. One is the PEM, of course, where there's this, fuss about low temperature, high temperature PEM cells,
Mm-hmm.
and then there's the solid oxide fuel cell. Is there any way for you to describe what would be the advantages of the solid oxide fuel cell as compared with the PEM cell? I've already heard one of the former advantages of the PEM cell you've dealt with. The PEM cells you can turn off and on, and the solid oxide fuel cells where, oh, no, we don't do that, but now we do. So what advantages are there, or what are the differences between the two?
I think, it's sometimes easier to think about consumer out. So if you think about applications in residences, so you have multifamily apartments, many of them have a lot of space limitations. So the footprint of the system needs to be it's very important that you have a small system, right? Now, the benefit of solid oxide fuel cells is that it simplifies the system that you need to operate the stack. That means you can actually think of miniaturizing the entire system as the consumer sees it, which means now apartment complexes are clearly an option. For example, if you we talk about one of our target areas being in Japan, space is really a commodity there, so we have to have very, very tight small systems. And this is very, very important. The second thing is, as I mentioned to you, some areas have kerosene, some areas have LPG or liquefied LPG, and other areas have natural gas. So you want to make sure that you're able to reach this wide audience. And I think that's a big benefit, right? The last one, which is something that we don't think about, is this, right? We talk about combined heat and power, but clearly the electricity has a lot of value compared to the heat, right? So this system, SOFCs in general, can have very high electrical efficiency, which means you're producing more of the value-added product, which is electricity. What that means is you could probably have a system that makes sense in a warmer climate and a very cold climate. So you don't need to depend on the heat fully to monetize the system. Okay. That, I think, allows a wider dissemination of the product, finally. Yeah.
I certainly know that here in Germany, the electrical bill, by comparison, with Massachusetts, we spend a lot more per kilowatt hour than you do, and that leads to my next question. Where's the market, and where are you going with this product?
So, as I said, our estimate or understanding of it is that you have, of course, Europe as a big application area, Germany, UK, Benelux, parts of Benelux, Italy, and but then you cannot forget Japan. I think Japan has a unique situation because of the fact that they need to have new infrastructure to generate electricity, and that's a big market, right? And what is also ignored is actually the US. So when we think of US, we think about 100 megawatts, 5 megawatt systems. But our estimate says that US is a good market, especially in the Northeast, in New York, for example, California, Texas, and if you like very rural environments, Alaska. But so the US also is a very big potential market for small systems beyond just Europe and Japan. So I think the reach is good. And one of the things when we look at it from Saint-Gobain's point of view, we are a large company, offices everywhere in 64 countries, that we want to be able to, we have the reach across different countries. So we want to be able to take advantage of what is being set up in our company to be able to connect to different geographies. Yeah.
Have I missed any questions from the audience? I know there's a lot of very specific questions that really need to be dealt with at the booth. Narendar, you're so knowledgeable in this field. It's been a pleasure to talk to you. I do encourage everyone to visit the booth of Saint-Gobain Corporation at C77, just around the corner there. I've found this a very fascinating talk. For the first time, I've actually thought about the issue of cycling off and on. It's been a topic that people have not addressed because the solution was not there. By comparison, it's fascinating for me that even PEM cells are particular if they have a reformer about low caloric or high caloric natural gas. So there's already issues here of, is it coming from the North Sea? It's a problem, or is it coming from Russia? And for you, it's a one-size-fits-all unit. You eat everything on your plate.
From our stack point of view, yes. That's
so
our game.
I think that's a wonderful thing. Okay, it's been a pleasure talking to you, Yeshwanth Narendar. Please visit him at the booth, and I hope you'll be back next year to tell us your success.
Thank you very much, and thanks for listening.
Thank you.
Thank you.